Hello everybody. Purpose of this video is to show you how I deployed the eShopOnContainers microservices application to Azure Red Hat OpenShift. So let me start out and just kind of show you a little bit what this is all about. I'm going to go to the GitHub project, and let's go to the project right here. This is the this is a pull request that I've done into the .NET architecture / eShopOnContainers GitHub project. So the eShopOnContainers project is pretty cool. It's just a kind of like a experimental canonical example of microservices done using .NET Core applications. And to kind of show you what that looks like, this is the solution that I'm using, the eShopOnContainers services and web apps. And the main client I'm using is the web MVC client. So that's going to be the UI. And there's several microservices. So we have, standard e-commerce application. We've got a product catalog, a basket, ordering, payment, identity for using identity server to authenticate users. There's also some what are called API gateways. So it's kind of like a facade in front of these backend microservices. So the UI can talk to the gateways instead of talking directly to the microservices. You can find out more about that on the main GitHub site for eShopOnContainers. Purpose of this though is to show you how I've deployed this to OpenShift. When you run this locally, obviously it's gonna launch up, a bunch of Docker containers. So if you'll see in all the containers here in the Docker compose file, there's a lot of what I call infrastructure. So there's SQL Server, MongoDB, SEQ, RabbitMQ, and then you have all the other applications. So these are all the microservices, identity API, basket API. And then there's ordering, background tasks, some more API containers. And then these are the API gateways. So that's using a Docker image called Envoy. So Envoy is an open source project for doing basically like an API gateway, BFF API gateway. And there's gateways for mobile shopping, mobile marketing, and then web shopping and web marketing. Now, obviously, not obviously, I need to explain to you, I didn't implement a mobile application with this. There is a Xamarin application that you can do. I've just done the web SPA and the web MVC, those two front ends, and I haven't even exposed the web SPA and tested that one. I haven't exposed that as a public website, but the web MVC project is exposed as a public website, and we'll take a look at that in the Red Hat OpenShift cluster on Azure. So then there's also the concept of these aggregators, which will go out and kind of aggregate some data between the different services. And when I say services, really the microservices. Everything running in a cluster is considered to be a service. But these are all services basically. This is the main UI that we're going to be using, is the web MVC. So that is, and there's the rest of the gateways I was talking about. So my goal was to get this stuff into OpenShift. So I have an OpenShift cluster, and let me bring this down here. So it's called, the project that I have is development, which is basically like a Kubernetes namespace. So this is the OpenShift development project. You can see here is Azure Red Hat OpenShift. And I've already deployed this. I've already built and deployed all the services here. So you can see everything's been deployed. All the pods are running. What I want to show you though is how I got it there. So for example, let's look at like one of the basic APIs, the basket.api. It's one of the simpler ones. Let's look at how did I get that there? So in the eShopOnContainers project before my pull request, there's a build and deploy folder. There still is. What I've done in the build folder, so they have ACR build, that's for Azure Container Registry, and then the Azure DevOps folder is for the Azure pipelines, so the build pipelines, and they do it a little differently in here. So these pipelines do, they do stuff that's kind of all kind of hard coded for Helm, which is cool. I've chosen to not use Helm and just use I want to just use the everything that is like out of the box OpenShift. So I'm using OpenShift templates. So I created this ARO folder, Azure Red Hat OpenShift. So this ARO folder here is all new. I didn't modify anything. I'm only adding new configuration here, new code. And so if I go into the Basket API, see here I have the same Azure Pipelines.yaml file, but it's a little bit different. This one, it's actually calling, it has two jobs. Each job is calling this reusable templates that I've made. So one template is for building the artifacts, and then the other template is for actually taking those artifacts and building a container out of those and putting those into the private OpenShift registry inside my project, my cluster. I'll show you how that works. Now, before we do that, you'll notice that I have this, take these parameters, OpenShift service connection. Well, actually, let's jump into let's just keep going. We'll go into the template. So build artifacts, that should be pretty familiar with everybody. So that's, we're doing a Linux build, we're using, we're doing the, using .NET Core 3.1 SDK. So we go ahead and make sure that that's installed on our build agent. Then we do .NET Restore, .NET Build, and then .NET Publish, and then we actually publish the artifacts, which is important. So that what we've published, we're in the .NET, in the .NET CLI publish command, what we've published there, we want to go ahead and so in that .NET Core CLI task, we want to, we're doing a publish, and we want it to go to the artifact staging directory, and then we say, okay, this is the project, so build, or just like we've done with the other ones, publish this project. And then this is the important part. So publishing those build artifacts, because we need those artifacts in the next job. So the next job, so this is the template for build artifacts, which we just looked at. The next step in our job, I'm sorry, I shouldn't say job. The next, it is a job. So the next job is the web container build. So the web container build is another template. Azure Pipelines template. It is a job template. And you can see here, it's this one, it's a little bit more involved. This is where we're actually touching the OpenShift cluster, because what we want to do, the purpose of our builds is to actually create a container and push it to that OpenShift registry we're targeting the development project in our cluster. So the strategy we've chosen here is our builds are always going to build and push images or containers to our development project. And then the thinking is when you have other environments like QA or prod or staging or whatever, you can just promote those same images that your build created. You can promote those using image tags. That's kind of the best practices way of doing it if you read the OpenShift documentation. So what we do here, what we need to do is we need to set up a connection to our OpenShift cluster. So I'm going to jump back and go to let's go to I have an Azure DevOps project, but it's connected to my GitHub repository, my GitHub repo. So there's nothing in the repos here. It's because it's everything is coming from the GitHub project. In particular, my branch, the feature branch for OpenShift on ARO. So what we can do though is we can look at, well, what I want to show you first is the project settings. I want to look at that connection to OpenShift. So if I go to service connections, you'll see I've created a service connection called OpenShift on ARO. So this is I had to actually download this plugin from Red Hat. If you just do a search, you'll find, just do a search on OpenShift Azure DevOps plugin, you'll find it, no problem. And you can see here it's doing token-based authentication. So I got with the token. Token's easy to get. I'm not going to go into how to do that. That's pretty straightforward. So I got an API token, I gave it the name, and I told it to, I always say accept untrusted SSL certificates, because if you have a cluster that maybe you don't have, on ARO, the SSL is good, but maybe if it's a local cluster or something, you don't have that. So I just got into, probably shouldn't do that, but anyway, it works for now. This is all just for test, there's not a working production application. And then I make sure that all the pipelines have permission to this service connection. Okay, so back to code. All right, so in this job template, my step is to set up the OpenShift command line interface tool, CLI. So that's what this does. This downloads the CLI and actually connects to the using the OpenShift service connection. And then what I do is I need to make sure my context is the right project. So I do OC project, which makes sure I'm setting myself to the OpenShift project passed in, which is development, which is actually right here. So this parameter passed into the template. Project name is basket.api. OpenShift project app name. This is interesting. In the Docker containers, when you run it locally, it's basket.-api, but you can't use that in OpenShift. The dash doesn't like that, so have to take that out. So pass these parameters in, and this is where I'm setting the project context to that development project. And then the next thing I need to do is I need to get the pipeline artifacts that were created by the previous job. So I grab those. Then the next thing I do is I need to execute a template. So this is kind of cool. There's an OpenShift template. I call it's app build template. And let me show you that real quick. The app build template, it builds out a build config object and an image stream object. So the build config says what kind of build we're going to do. And so we're doing what's called S2Y, source to image, and we're going to use the binary. And then what we're doing for the strategy is it's an image stream tag. So basically what we're saying is we're going to build off of Red Hat's .NET 3.1 image. So the .NET 3.1, .NET Core 3.1 image that's already in our private OpenShift Docker registry. We're going to base our image off of that, and that's actually in the OpenShift namespace, which is kind of like a global project in every OpenShift cluster, and that's where all the images, all the Red Hat approved images go. Next thing we do, so that sets up the build config. So, and it says like, okay, we're gonna, it's gonna be an image stream, and that's the name of our image stream is whatever we pass in. So in this case, it's basket API. and then we actually create an image stream for it. So when we do the build is actually going to build a container and put it into this image stream wrapper. And we pass, here's the labels for it, which is application name, and then the name of the image stream is the application name. And that is it. That doesn't deploy it. That just puts it. If this didn't exist before, all this is going to do is create an image stream and put a container in it, but it's not going to be deployed yet. It will put it in there though. So if I go into my OpenShift console and I go to builds, I go to images, I go to Basket API, it's going to create this. It's going to create this this image stream called Basket API, and it's going to have the image inside of it. So it's going to push it's going to actually create the Docker image. That's the S2I technology, and it's going to push it into this image stream. Okay, so back to code. So that's what this does. All this does right here does that build. So let's go ahead and just take a look at it and let's just do that build. And let me go into pipelines. So I went in and set up all these pipelines based on these YAML files I created. So if I come in here and I edit it, you can see this is coming from my feature branch. So this is the actual code right here. So I'll just go ahead and run this. And it's going to build the app. Or I'm sorry, it's going to run these two jobs. It's going to run that restore build publish job and then the container build job. This one takes a while to run because the .NET restore takes a little bit of time. So I think what I'm going to do is we're not going to wait for this, but I can kind of show you. So I've kind of showed you this is what it looks like. And you can see here it's created these, it went ahead and created that image. So that's everything for build. That's how we build these microservices out. I think I'm going to go ahead and stop here, and I'm going to do another video that covers how the deployments work. So let's go ahead and stop now. I'll stop sharing, stop presenting, and I'll go ahead. Actually, you know what? Let's just go ahead and I'll just stop recording. Okay, everybody, we're back. Go ahead and let the build finish that we were talking about. We can kind of see what happened here with the restore build finish. That one's pretty simple. Everybody does that one all the time. But you can see the publish the artifacts, and then this is the more interesting one, the container build. And actually, I need to step back to Visual Studio Code for that one again. So we were looking at the app build template. We got through that, but then once we've gotten the build template there, we use the OpenShift CLI. And so you can see here, we're doing oc.exe, and we're calling start build. And start build, we already have the build config of our app, which is our app name, which is Basket API. So we already have a build config for Basket API. And what we're then doing is, because we've downloaded the pipeline artifacts from the previous job, and we know that the artifacts are in a folder with the project name, so basket.api. So we do this start build from that directory, and it's going to upload all those artifacts, and then follow and wait. Follow means we want to see everything logged to standard out, and then wait just means wait for it to finish before continuing. And then this is all just PowerShell stuff here to Make sure we get the standard output, standard error. Checking to see if we had any errors. And if we go back to the build, you can see here, here's where we did the OC setup. So that's interesting. That's where it downloads the CLI tools. And it's using, so you notice how it's using a different project there. So that's why I have to set the project context. So now we're using project development. That's our target. That's our target namespace that we want for these container images. Then this step here, we're downloading this pipeline artifact. So what we published for the basket.api project. And then this one is, we're just executing that build template file. So this was creating that build config and image stream. And you can see here, they've already been there. They've already been pushed out there, so they're unchanged, which is cool. It's idempotent. I can run this over and over again. That's the beautiful thing about OpenShift templates. OC process is pretty cool too, because what that does, OC process will take your template file and then split up all of its objects into an array, and then you can just pipe that to OC apply, and then you do that -f with a dash at the end, say there's no file name. So that's a kind of a best practice way of getting stuff provisioned into your OpenShift cluster, put it into a template. That's the way to go. And then here's where, this is the cool part. This is the S2I source to image technology. So this is where we're, the CLI is uploading that directory, basket.api. So you can see here, can't quite see the command here, but yeah, I guess it put it into a PowerShell file, so you can't really see the command. But basically, it's doing that build, and then you can see here using Docker registry.default service 5000. So it's pulling. This is the OpenShift project. That's where all those Red Hat images are at. So this is pulling the .NET 3.1 image down, and then building our image off of that. And so you can see here, upload the directory basket API, and that is it. So now if we go into our project in our cluster and we can see here, it's created it. So kind of looked at this already, but anyway, just to prove it's there. It was last updated 6 minutes ago, so that's because of our build. So cool stuff. All right, so now what we're going to look at, we looked at how to build the containers. Now we're going to look at, well, how do we actually provision these out to be, running as in pods, right? So as running in these applications and services and pods, all that good stuff. So the way that happens is I'm going to go ahead and close all these files and get out of the build directory. So let's close these guys up. That's the build. Now we have deploy. So deploy folder was always there too. All I've done is added an ARO folder. And the ARO folder, you can see here, there's some templates, but there's also kind of a one-to-one, same thing as the build folder, same type of hierarchy where I have basket API and then it has its pipeline. This is the deploy pipeline or release pipeline. And it should look familiar, but I am using some shared variables. So I have a template set up for my variables because I'm sharing these variables. I want all these variables to be shared, across my cluster. And so here I have in the DevOps templates, I have this variables file, and so there's a whole bunch of variables here, and you can see here, it kind of depends on the OpenShift project. So that's like at the stage level. So that's why I can reference that here, because that gets kind of overridden at runtime. And so in this case, it's always going to be the development project, because that's what my stage is set. It's using right now. But I'm building up all these different URLs, health check URLs, host names, connection strings, SQL host name. There are some secrets that I use that are kind of, I'll go into that in a little bit, but there are some secrets that get used to kind of get consumed as build variables or release variables, I guess. So let's close this out. Well, let's leave that open. So the Basket API deployment, we get our variables from the template. First thing we have to do again is we need to set up the OpenShift CLI because we're running from scratch. Next thing we do is make sure we're running in the right project, and then it's pretty simple. In this case, we have a template. We have an OpenShift template, deploy template for Basket API, and it has a parameter that we pass in, a couple parameters. So this image registry project name, that's like source image registry project name. It's development, right? So, but I decided to call that out and give it its own separate variable name and parameter name, because it could be, who knows, if you change that later on, you don't want that to be hard coded. And then there's some other parameters that this template takes. So the identity URL, so that's for identity server, the public URL for that. And then this is just the private URL of that identity service. And it talks to Redis and it talks to RabbitMQ, so it needs those host names. And you can see here it's doing an OC apply. Same thing, same pattern. It takes the OC process, takes your template files, splits it up, splits all the objects up, and then you pipe it into OC apply. This is just really cool like that. So let's take a look at the let's look at the Basket API deploy template. So this template is, you can see here is kind of the standard nomenclature for how the templates look, the YAML for the templates, and then it has a list of objects. So the first object is the deployment config, which is kind of like a deployment in Kubernetes. And deployment config, I have my, got the spec here with the strategy, the rolling strategy. It's got some labels here for the metadata, and then the containers. Here's all my environment variables that I'm passing into that container, so that's important. The image, so this is the image that we created in our build. This is the that image stream. That's the that's where it's located. Now you could put, an actual Docker image in here if you wanted to, or you could point it to, wherever. It could be an ACR, Azure Container Registry, or Quay, or whatever. But I'm just using the built-in one with OpenShift because it's easy. You don't have a whole bunch of moving parts. You don't have to worry about that. There is so there's something that needs to happen before this deploy. We'll finish going through this, and I'll go back and, because you'll notice that this has some dependencies on RabbitMQ and Redis, that type of stuff. So there's some dependencies there. Cool. So that's the environment variables, and then that container has 2 ports. 8081 is for gRPC. This is just for the standard HTTP traffic. And then the triggers, I've set up a config change, and it's just automatic. So if the config changes, it's gonna redeploy this. So that's kind of cool because you can kind of do GitOps with that. So if you make a change to like the deployment config and you update it, then it'll just automatically, because of this trigger, it'll automatically do that. You can set it so it doesn't do that if you don't want to, but it's kind of cool with a GitOps flow. You can basically, if your PR gets approved and the pipeline runs, it's going to go ahead and push that out. Also, if the image stream changes, now this is, for right now, I just have, that it's looking at the latest tag, but if I was in a different environment like QA or test or prod or whatever, I probably would have tags for those environments. Like, so only push out it, push something out if it's been, if the image tagged with QA has changed, then push that out. But in this case, I just have one environment, so I'll just say latest here, just for simplicity of this demo, so it's not super complicated. And then, so that's the deployment config, and then I have the service. definition here. So it's, all the ports that we're using. And so this is how other services can contact this service. It has this, you define what the service is, it's going to generate a host name for you automatically, and then these are the ports that listens in on. And then here's all the parameters coming in here. So I love the idea of the parameters to template. You can get reusable templates. That's kind of cool. Okay, so that's pretty much everything for getting that deployed, but we do have some dependencies. And what I've done is I've just called those infrastructure. So infrastructure to me is all the the databases and the Redis cache. There's also secrets, so we'll talk about those last. So this is MongoDB. So obviously, I'm just using the Docker image for MongoDB, and all that is set up here though. So you can see. So here's my deployment config. And what I've done here, so this is the image is application name list. Let me scroll down to, there's a service, that's all pretty standard. But what's interesting is the image stream. So this is where we get the container. So I'm pulling the image stream from Mongo. So this, when you don't specify anything, you just say the name of it, then it's a Docker image. So yeah, Docker image name is Mongo, and I want the latest. So it's going to pull the latest Mongo Docker image into my image stream, right? So it's going to get this image stream populated, and it needs these magic annotations here to make that happen. If you don't have those, it won't happen. Let's go ahead and take a look at that real quick. If I go to, let's go back to builds and images and go to Mongo. This got populated because of that image stream object. So this is showing, this happened 11 days ago. And that's all stuff that was just part of that Docker image. Okay, so let's jump back to code. So that's important. So we got the kind of a standard template here for these microservices is we do the deployment config, to get the container configured with all the environment variables, all the good stuff, triggers, and then ports, obviously. And then we got the image stream, which we just talked about, and the service. So those three things, those are like the basic things here. And then we've parameterized everything. And I know that application name is Mongo, so I hard coded the value. I give it a default value, but I like that because then I can just use that application name everywhere instead of typing in Mongo and accidentally misspelling or something. I use a variable there for that. So that's Mongo. SQL Server. I'm going to look at SQL Server last. RabbitMQ, same thing. Everything here is pretty much the same. It's got a few more ports, but same exact pattern. We get the RabbitMQ with the 3-management-alpine tag from Docker. Same thing, Redis and Seek. Now SQL Server is a little bit different because SQL Server you need to pass in an SA password when you want to run this container, this Docker container. So one of them is accept EULA. You just say yes. The next mandatory parameter is SA password. Now I don't want to hard code that in here. I don't even want to pass it in as a parameter. So what I'm doing is I'm saying, hey, I want to get this from a secret. So what that means is there's some secrets that need to be deployed. So I have a template for deploying secrets. And actually, if I go back to Azure Pipelines, if I go back to my, let's see, that won't be in here. So if I go to the Azure Pipelines for infrastructure, let's close the Azure Pipelines for Basket API because we already looked at that. So this is the Azure Pipelines YAML file, the deploy deployment or release pipeline, the Azure Pipelines YAML for infrastructure. Same kind of stuff here. There's just a bunch of jobs with some variables. So here I'm building out the variables for the SQL host name, and then actually building out these connection strings. Now you'll notice that there's a SQL password variable there and a SQL username one. Now, those aren't defined in my variables template. Those are actually coming from Key Vault. So what I've done, let's see if I can, yes, okay. So what I've done is I have a task here. I'm using the Azure Key Vault task. So what that does is it connects to a Key Vault. So it's connecting to this Key Vault name here. And basically, it's just taking all the secrets that I have in the Key Vault and turning those into build variables or release variables, I guess. I'll call them build variables in Azure DevOps. They're ephemeral, meaning they don't persist to the logs. You can't see them in the logs, so it's safe to do this. But then that's how I get this. That's how I can reference that variable though, or that, yeah, because that's becomes a build variable. So SQL password is coming from Azure Key Vault. And it can come from anywhere else, but that's just the way I decided to do it. And so then here, obviously the first thing I need to do is deploy those secrets. So I got the secrets deployment template, and then let's look at that. So that basically takes all those, it's pretty simple. It creates these secrets, gives them all a name, and then the key or the connection string is the key, and then the value here. So it takes all these parameters right here. So nothing hard coded. All the connection secrets and password secrets, all that stuff, it's all parameterized. So from here, you can see I've already built out. So these parameters, I got to fill them in, but I've already built those out, right? I built those variables out up here in my in my job. And so because I've done that, I have those values. And that's kind of nice. I don't need to worry about, those secrets, sticking around and being, going through the logs and being able to find them, that kind of stuff. It's kind of safe and secure this way. So these all just do the same thing. They all call these templates OC process on it, piping it into OC apply for the rest of all these, what I call infrastructure containers that are running, or pods, call them containers. So that is the infrastructure, and that's how Basket API was able to run. So now what I can do, and we looked at the variables. There's some more interesting ones here. Let's just do a demo right now of deploying Basket API. So I'm going to, let's go to the overview. Let's get Basket API expanded. And I love this UI because it shows like, hey, I got one pod right here. I can increase the number of pods I have running. That's the beauty of Kubernetes and OpenShift, right? Because I have a service. The service acts as a load balancer to all these pods. Right now, there's only one pod. But if I have 10 pods running, I still just reference it by the service and the port, and it just does like a, it does the load balancing for me. I don't have to worry about that. So very cool. All right, so what I'm going to do now is go back into my pipelines, and I will go to I just created these folders. So I created a folder called Release Pipelines. I'll go to Basket API Release. And just to show you that it's not smoke and mirrors, let's edit that. And you can see it's the same file we just looked at in Visual Studio Code. So same stuff here. And I'll go ahead and run that. Make sure it's going to the right, pulling from the right branch. Run that. Now these run pretty quick because it's really just kind of just doing that. It's not uploading files or anything. It's just doing this basically configuration. So it looks like it's queued up here, I guess. Oh, there it goes. All right, so it's going to set up the OpenShift CLI first, and then set the project context. And then the ensure Basket API deployment config, that's where it's going to execute that template, the OpenShift template. And that is going to cause the deployment in the development project, because we want that to be, continuous deployment going on there, because it's just looking at the latest tag. So this step takes a little bit of time, just downloading the CLI. Then the project context is fast. Now I'm going to switch over, and I'm going to go over to the web console. So you can see here, OpenShift just is provisioning that new pod for me. But it was cool because it kept the old one running. And now that the new one's up and running, it destroyed the old pod. So I had no downtime during that deployment. So you can deploy as many times as you want in a day, as long as your code obviously doesn't have errors that's going to make the pod crash. But you can deploy anytime you want, and your app is going to keep running. Your service will stay up. So that's pretty cool. All right, so that's the deploy of the basic API. Now let's look at a more interesting one, like catalog API. Is it has a public route because it exposes the pictures for the product catalog. So it's there's an API for public API, because obviously you have an image tag in your HTML and it has to point to a source, and the source is pointing to this public API, right? So that got exposed as a route. So catalog API, it's bring these back here. So catalog API, it's almost the same thing as Basket API, except there's the extra part is the route, right? So everything else here is the same. Well, actually, I should take that back a little bit. So the only extra functionality I need to deploy that route. So I tried to put the route into the OpenShift template, but the route contains certificate data. So let's take a look at this route. So there's you need to put in the private key certificate and the CA certificate. So what I've done here is I couldn't use template, so I couldn't use parameters. So I'm just tokenizing this. And so in my pipeline, I actually replaced those tokens. So I'm using the this task by Collins ALM Corner. It's the replace tokens task, which is fantastic. And the path, this is the path to that that's housing the catalog public route JSON file, and then this is the file name, catalog public route JSON. So as long as your build variables or release variables match what's in your file, what's in the underscore variable name, then it just automatically replaces them. You can set it to not do all of them, but it's easier just to do it this way. I'm just doing all of them. And so you can see here, I'm just taking the service that was created in my catalog API, and I want to expose that using this host name and using target port, and then I have to pass in certificate information. So the certificate information lives in Key Vault as well. So these three items they just live as basically just plain text secrets. I just took the data from the certificate file and put it in a Key Vault, and it brings it down. But I had to do it as JSON here with quotes around it in order for that certificate data to stay intact. It just kept getting messed up. So that's why I did that. And so then that deploys out exposes the service as a route. And it gives me, and I have, there's build variables in there that get created. So let's see here. Let's see, I have an environment name here. This is dev microsoftmbu.com. So we have that domain name. And, because I'm including the variables, if I go to the variables, you can see that there's a catalog public host name right here. So that just gets built up. So I have API host name, catalog API URL, and then there's a one for gRPC, and this is the public hosting. It's just catalog, plus the environment name, which is, so it's catalog-dev.microsoftmbu.com. So that's how that works. That is for the doing a public route, which catalog API has. So that's pretty cool. That is the something a little bit different than the regular simpler basket API. The other ones that are a little bit more complicated, and we've gone through all these infrastructure ones. The other ones that are a little bit more complicated. Well, let me take a step back. So I had to publicly expose catalog because of the pictures, and then I had to publicly expose identity, our identity server, because the user needs to get redirected to the identity server to authenticate, get their token. And then I obviously had to expose the public website. So the web MVC application, I had to publicly expose that. So this is, what you see when you run the site. This is all being served up from OpenShift, our cluster. And if I expand that, you can see here, it looks the same. Here's the public route right here. And if I go into the public route, we can actually even go in here and can edit the YAML on that, and you'll see the, here's the certificate data right there, private key. It's exposing that web MVC service. And it uses the built-in router inside of OpenShift. So pretty slick. All right, so we've here's a basic microservice. Here's a microservice that has a public route. And the next one we need to look at, this is the last one, is the API gateway. So this one's a little bit different, a little bit trickier because it's using that Envoy Docker image, and it requires a configuration file, envoy.yaml. So let's take a look at that. This one, let's see here. And the other thing about this is that before I go there, let's take a look. So let's look at mobile marketing API gateway. We're not using that. Let's look at web marketing API gateway, because we're not using the mobile ones. They're out there, but we're not using them. So here's the pipeline. Pretty simple. I made a temp, since all the gateways are basically identical except for their name and title. I made a template, an Azure DevOps template for that I call. And now I do need this envoy.yaml file. That's important. And this actually does get, there's some things that get replaced here. So you can see here, this is how the handles like the gateway, port forwarding and stuff. So it has these things called clusters. So there's a marketing cluster, locations cluster, and they point to the marketing API service and the locations API service. And you can see with the address here, I've tokenized the address based on the project. So that gets replaced. So I have a step in the, when I call this template, the template knows to replace the values in that envoy.yaml file. So let's take a look at that. So this template is actually pretty cool. So it does, has the same standard thing we've been seeing before. It's got the deployment config, and that's all kind of standard. However, we are defining a volume for it, because so this Envoy app, it needs to have that envoy.yaml file, and it's got to be, you have to tell it what directory to find it in. But there's no storage, right, in containers, so we have to actually define a volume. And what we do is we're actually to get our physical file in there, we're using what's called a config map. And so we have to create that config map first as well. So let's go back to okay. I'm showing you the wrong template. This is the Azure DevOps template. This is the template for all the OpenShift objects, which is fine. We're looking at the deployment config. That's fine. So let's go back to web shopping our web marketing API gateway, right? So this is calling this Azure DevOps template. So API GW deploy. So that is this one. So this is our Azure DevOps template for this job. So I call it the job API gateway deployment. And I pass in the title. So the title and then app name, obviously we're using variables. We need to replace the tokens in the envoy.yaml file that we just looked at. So because we use the same name and file every time, and it's always in that folder, we know that we can find it. We know it's going to be, you know, the app name is the folder name. We're using that convention, and it knows to find the envoy.yaml file. So cool. We tokenize that. We replace the tokens. Same old step here with getting the OpenShift CLI set up. Same thing, project context. That's cool. So this stuff here is the interesting stuff. Is we need a config map. Now we can't really. We could make YAML for the config map, but we need to get. There's a way in OpenShift where you can create a config map from a file. We could, you know, take that as file, that YAML file that, you know, gets all escaped and turns into like JSON and all kinds of stuff inside of OpenShift and put that in our template file, but that looks nasty. So the better way to do it is to we suck in that envoy.yaml file every time. But one of the things the only way we can create a config map like that is we got to do OC create. So OC create, if that already exists, it's gonna throw an error. So what I've done is I just do an OC delete, because I want to know, like, if there's changes to the config map, I got to get, you know, I have to delete the old one and provision the new one. So it's going to try to delete this. And what I did here is if it's the first time you've run it and you don't have the config map, it will fail. But I just say, hey, continue on error true. You'll see a little orange icon the first time you run it. Every time you run it after that, it won't be there. And that's cool. It deletes the config map if it's there. Then this is the important part. So it creates the config map from the file, right? So that's from the, this is the right directory based on the app name, and then envoy.yaml, which is cool. This is in our Azure DevOps pipeline template. So we've got the config map created because it needs to be there, right? And then once we have the config map created, we can go ahead and call this deploy template, because that deploy template needs that config map to be there, because it's mounting it as a volume. So we have a volume called config, and you know, here's the key in the path, envoy.yaml, and in our container is referencing that config map. So let's look at the config map real quick and just see. If we go into resources, config maps, let's look at that web marketing config map. Sometimes it shows up, sometimes there it goes. Okay, cool. So here's our envoy.yaml file. So you can see here that this is the key and that's the value. So the key is the file name, which is perfect. That's what we want. So that we can actually reference it as envoy.yaml as a file. So if we go back to code, you can see here, we give that, where is that? Trying to look for the volumes. Oh, here we go. So we're mounting it in this path, etc envoy. So that's important because the Docker image looks for that path. It looks for a path called etc/envoy, and then the file name it looks for is envoy.yaml. So we've actually, it's like a virtual file path, right? And with a virtual file, and the config map acts as that virtual file. And so when the container calls for that file, because it's backed by that config map mounted as a volume, it's able to pull in all that YAML that it needs to do its job. So that was a little bit tricky getting that figured out, but that works pretty well. And again, all the same stuff here. If it triggers, it's going to redeploy if you change anything, you know, in the config, or if the image changes. And then again, the service, it's got a couple of different ports, 8080 and 8001. And then and then the image stream as well. And that's the same thing that we've seen before. It's pulling from the Envoy proxy / Envoy version 1.11.1. So this is a reusable template, which is really cool because our pipeline, we just call that template, and that template does everything. All we have to do is just give the app name and the app title into that Azure DevOps template, and then the Azure DevOps template calls our OpenShift template, passes in the right arguments, and that's how we get all of our those API gateways deployed. So that covers everything. That's how everything, all of these applications have been deployed, all these services, microservices, or whatever apps. This is how all of them have been deployed into our OpenShift cluster. And you can see here, it's not smoke and mirrors. I can log in. You can see here, it's going to my identity server. That's that public route that we exposed right there. And I log in, it's going to redirect back to the eShop. So we're good. And I can go ahead and take a product, add it to my cart. Take a look at my cart. I can do a checkout. That looks good. Place my order. And I'm good to go. So I placed my order, and then if I want to go back to the catalog, I can do that, back to the catalog, or this does the same thing. So anyway, that is that's how this works. This hasn't been integrated into the GitHub project yet. There's a pull request for it. Here's my pull request, and this should be in there hopefully pretty soon. But yeah, this is all done with the YAML files, with Azure DevOps pipeline YAML files and OpenShift template files, and OpenShift YAML files. So hope you like it. Feel free to hit me up, tim.mccarthy@perficient.com. I'll put my my contact. Well, you have my contact information on GitHub. So I'll put a link into this video into the READMEs on GitHub. Thank you very much.